Greetings, math fans. All right, so this is Note Sheet Day 4, and today's topic is combinations. All right, very, very, very important. So it even says here, combinations like permutations are subsets of a set. Repetition is not allowed, so this is just like, is not allowed. So this is just like a permutation, no repeats. But a combination differs from a permutation in that order does not matter. That's huge. It doesn't matter, right? Remember, it mattered before because when you picked a group of people, it's if I'm doing president, vice president, secretary, treasurer, that order matters. Now what's happening is I'm just saying, hey, come on, I need a group of 10 people. Come on with me. All right. It doesn't matter if I'm picking, which person I'm picking first, second, or third. I'm just grabbing 10 people and they're all coming with me. So some of the key words that you're going to look for with a combination are the words like if I could say a group of people or a list of people or a committee of people. Okay. First example is it says list the combinations of these 5 elements from A, B, C, D, E, taken 2 at a time. Well, let's just kind of list them here. It's like saying A, B, A, C, A, D, A, E. Okay, and then if B is first, I'm going to say B, C, B, D, B, E. And C is first, so C, D, C, E. And then D is first, D, E. Right? So there's no, the order doesn't matter. Because if order mattered, I would be listing BA. And I'd be listing CB, right? All those different things. But BA is the same thing as AB, CB is the same thing as BC. So if I count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10 number of combinations is 10. Okay? So let's look at number 2. Find the combinations of ABC taken 3 at a time. Well, how many ways can I arrange those that ABC? There's only one way, right? It's just ABC. I mean, if I say CBA, order doesn't matter. So CBA and BAC and CAB, I mean, they're all the same because order doesn't matter. So the number of combinations is 1. All right, so here is the nice little friendly formula you're using for combinations. NCR, okay, which remember using your calculator, NPR. Now we're going to use NCR. And the only difference between NPR and NCR is this guy right here. We're dividing it by R factorial. What that R factorial does is basically eliminates duplicates. And duplicates meaning, like you said, B and C and C and B, right? Anything that where there's order. So it eliminates those duplicates or the repeats. All right. As we said before, for permutations, N is the total number, and R is equal to the, it's like saying groups of blank. Okay. Another notation, so it's NCR. This is another notation, and it's written like this. I'll write it out a little bit bigger here. NR. All right. You got to know that top number is your N. So if I said, 5, 2, that's like saying 5C2. Okay. How do you remember that's a combination versus permutation? Look at the parenthesis. Isn't the parenthesis look like a C? So it's a combination. Combo. Okay? Not a permutation, it's a combination. So make sure you're good at that. All right, so let's just take a look at our calculator real quickly here. Well, actually, let's do this problem. I will select 5 students in this class to get an A. How many ways can I make a selection? So, it all depends on how many students. Let's just say we have 31 students in the class. It's 31C5. That's 31 factorial over 5 factorial, right, R, times N minus R factorial. Okay, and if I type that in my calculator, I get 169,911. Let's check out our calculator here. If I put this on the TI, so it's 31C5. So we're going to do 31, math, cursor over to probability, and now we're going to use 3. 31C5 and 169,911. Sweet. Sweet. Okay, pretty easy. All right, so let's do some more examples here. There are 20 players on a basketball team. How many ways can a starting team of 5 be selected if every player can play any position? Guys, you need to understand this wording here. Sometimes people get confused and they think it's a permutation because they think order is important. The reason I say if every player can play any position is then there's no order, because I'm saying on a basketball team, you can play forward or center. It doesn't really matter what position you play. So that's why order doesn't matter. If I specifically said you have to be forward, you have to be center, etc., that's an order. That would be a permutation. So those words, know those words. Every player can play any position means basically no order, which is definitely a combination. So that's just going to be 20C5. And you put that in your calculator, and you get 15,504. Okay, example 5. Using the 20 players from example 4, how many different teams can be chosen if Russ must start the game? So here's the deal. That means there's one less person to pick from. So it's not, instead of 20, it's 19. One less person plays, and I'm picking how many? Well, before I picked 5, but one's got to play. So now I'm only picking 4. So it's 19C4, which is 3876. Okay? Example 6. A mud wrestling team is made up of 5 males and 5 females from this class. How many different teams can be made? All right. So it all depends on how many people we have here. But if I do, let's say we have if we have 31 people, we have 16 males, and we're picking 5, and so it's multiplication, and let's say we have 15 females, and we're choosing 5. Okay, so let's actually pull that up on our calculator. Just do it. Move it over here a little bit. Okay, so it's 16 C5 times 15 C5. Okay, hit enter, and we get 131,17104. 131,17104. Okay, so that's a lot of different possibilities. Okay, again, order is not important. All right, example 7. You have a penny, a nickel, a dime, and a quarter. How many different sums of money can be formed? Well, again, it doesn't matter if I have a dime first and then a nickel and then a quarter, or a quarter first and then dime and then a nickel, right? It doesn't matter the order. What matters is how many am I choosing. So this is the deal. I can either choose 1, 2, 3, or 4 coins. So if I have 1 coin, let's just list it. 1 coin, 2 coins, 3 coins, and 4 coins. Okay, so if I have 1 coin, I have 4 coins to choose from: a penny, nickel, dime, and quarter. So that means I've got 4 and I'm choosing 1, right? Or, the word or means plus, very important. Or I'm choosing out of 4 coins 2. Or I'm choosing out of 4 coins 3. Or out of 4 coins I'm choosing all 4. Okay, so these values are 4, 6, 4, and 1. This 4C4 makes sense because if I'm choosing all 4, there's only one way to choose all 4: penny, nickel, dime, quarter, right? So anyway, I add all these guys together, and I get 15. So there are 15 different sums of money that I can form. Okay. Number 8, there are 6 blue marbles, 8 red marbles in a jar. How many ways are there to choose 4 marbles if at least, ding, 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 keyword, math fans, at least, that's huge, 2 must be red. So if I'm picking 4 marbles and 2 must be red, I'm either going to have 2 red, 3 red, or 4 red. And notice the words, or. That means it's going to be plus between them. So if I have 2 red, that pretty much means I have 8C2, And I'm picking 4 marbles total, right? So that means the other 2 out of, so the 6, right? I'm picking 2 of those. And 3 red means out of 8, I'm picking 3 red. And out of the other 6, I'm picking 1 blue. Or I'm picking all 4 red and no blue. Okay? If I multiply all that and add it together, I get 826. Okay, so let's do another one. These are good problems, though. You guys need to know how to do these problems. There are 8 blue marbles and 5 red marbles in a jar. How many ways are there to choose 3 marbles if all of them must be blue? So I'm choosing 3 marbles out of 8. So do you guys agree this is out of 8 blue marbles, I'm choosing all 3 of them? And then what about for the red marbles? Out of 5, I'm choosing 0 of them. Right? So this 5C0 is really 1, because there's only one way to choose 0 out of 5. It's not choosing at all. It's just 1. So it's 56 times 1, which is 56. Okay? All right, let's keep going here. Example 10. This has to do with this whole page here. There are 4 blue marbles and 3 red marbles and 6 green marbles in a jar. How many ways are there to choose 3 marbles? Just 3 marbles. Doesn't say about any colors. So how many marbles do I have total? I have 13. So I'm saying what's 13C? 3, which is 286. How many ways are there to choose 2 marbles? Well, I have 4, and I'm choosing 2 of them. Now this is optional because I have 3 reds and I'm choosing 0 of those, and 6 greens and I'm choosing 0 of those. The reason this is optional is because each of those equal 1. All right, anything C0 equals 1. Anyway, so 4C2 is 6. 6 times 1 is 6. All right, and how many ways are there to choose 3 green and 2 red? So 3 green, which means I have 6 green, so it's 6C3. 2 red, which means I have 3 red and I'm picking 2. And 4 blue, and I'm choosing 0 of those, which again is kind of an optional thing. All right, and if you do that, you get 60. Okay, D, how many ways are there to choose 1 blue marble and 5 green? All right, so you got 4 blue to choose from. I'm choosing 1 of those, and 5 green. So it's out of 6. I'm picking 5. And again, you don't have to do this, but we've got red marbles, right? And there are 3 of them, and I'm choosing 0. So that's basically 4 times 6 times 1, which is 24. Okay, letter E. How many ways are there to choose 3 marbles if you select 8 marbles? Okay, so think about it. There are 4 blue, and I'm picking 3, but I'm selecting 8 total, right? So that means out of the other 9, because there are 9, if you add up the green and the red, that's 9 marbles, and I'm picking 5 of those. These numbers, math fans, have to add up to the number you're choosing. So it's 8, and this is like these 2 here are like a total. Not always, but a lot of times it's total. And this is how many I'm choosing. Okay, the 8. So 4C3 times 9C5 is 4 times 126, which is 504. Okay. F, how many ways are to choose 4 marbles if at least, there's again the key word there, it's underlined, 2 of them must be green. So that means I either have 2 green, I have 3 green, or I have 4 green. Okay, if it's 2 green, I have 62, and I'm choosing 4 marbles. And out of the other ones, if you add up the reds and the blues, it's 7. So it's 7C2. Or 3 green, which is 6C3, and 7C1. Right? Notice it's 4 marbles, right? 4 marbles. And I get all 4, so 6, and I choose 4, and there's no other marbles from the other one. So again, these add up to 4, these add up to our 13 total that we're picking from. So if I multiply all this stuff together and then add it, I get 470. Okay. G, and how many ways would it choose 6 marbles with no more than? No more than 2 are red. So that means 0 red, 1 red, and 2 red. Okay? So 0 red means I have 3 red and I'm picking 0. And I have the other 10, because there's 4 blue and 6 green, so that's 10. And I'm choosing 6 of those. I can do 1 red, so 3C1 and 10, and then I pick 1 less of the other ones. And this, of course, these are plus. And then I have 3C2, choosing 2 red, and I'm choosing 1 less of the other ones. So notice these add up to 6 again, right? And these guys add up to 13. Because that's the total number of marbles we have. Anyway, you multiply and then add them up, and you get 1596. Okay? Last page here. These are card problems. Okay, you guys need to know about cards. So let's just talk about this quickly. All card problems are combination problems. That's important. All card problems are combination problems. Very, very, very important. Okay. First of all, there's 52 cards in a deck. There are 4 suits in a deck, which means the club, the spade, the diamonds, and the hearts. Each suit, so each club has 2 through 10, Jack, Queen, King, and Ace. That's 13 cards. So 2 through 10, Jack, Queen, King, Ace. Each suit has that. And that's why there are 13 of those, and then 13 times 4 is 52, total number of cards. Each number has 4 suits. So, for example, for the 2s, you have a 2 of clubs, 2 of spades, 2 of diamonds, and 2 of hearts. This next thing is important as well. Face cards are jacks, queens, and kings. So there are 12 face cards. All right? A face card is not an ace, so don't get confused. Sometimes people make an ace a face card, but an ace is not a face. Even though it's got an ace in it, it's not a face card. And then if I say a 3 of a kind, basically what a 3 of a kind is 3 of the same number, like 3 2s or 3 aces, and other cards can be any cards. If I'm saying I want a 5-card hand. Okay? So let's get down to business here. Example 11. How many different 5-card hands exist? Well, there are 52 cards, and I'm picking 5 at a time. So it's 2,598,900. Oops, 960. Okay? How many 4-card hands exist? Well, 52C4, which is 270,725. It's like 1/10 of that when you're looking for 1 less card. Okay, C. How many 4-card hands exist that have 4 of the same suit? So what you're doing is you're doing one for, first of all, it's 13 in a suit, and you're picking 4. Okay? A 4-card hand that exists that has 4. That's why this is a 4-card hand, and this is a 4 down here. But they have the same suit. So let's just say this one is 4 hearts, and then you need one for diamonds, and then I need one, so 13C4 for spades. And then 13C4 for clubs. Okay, so I can do that, or I can just say 13C4 times 4, and I get 2860. Okay, hope that's good. Again, it's the same suit, so that's why there are 13 of them. All right, letter D. How many 4-card hands exist that have 2 aces? Well, there are 4 aces, and I'm picking 2. And how many of the rest of the cards? Well, 48, and I'm picking 2. Okay, so that's going to be 6 times 11, 28, which is 67, 68. Okay, E, how many four-card hands exist that have 3 of a kind? Okay, well, a 3 of a kind, let's talk about each individual one. How about the 2s? Well, it's 4C3, because there are 4 2s, and I'm picking 3 of them, but it's a 4-card hand. That means the rest of the cards, the other 48, I need to pick 1. So that goes for 2s, 3s, 4s, all the way up to Jack, Queen, King, Ace. That means there are 13 of them, so I multiplied that by 13. Right? I could add it all together, but it doesn't make sense. So that's multiplied by 13, and you get 2496. All right, F. How many 4-card hands exist that have 4 of a kind? That means 4C4. That's like for the 2s. And there's nothing else. It's a 4-card hand, 4 of a kind. And of course, if that's for the 2s, I need to multiply that by 13. And so I get 1 times 13, which is 13. Okay? Which makes sense because that 4C4 is 1. Because think about it. For the 2s, isn't there only one way to have, especially since it's a combination, only one way to have all 4 2s is by having all 4 2s. And then it's a 4-card hand. So that's it. Okay, letter G. How many 4-card hands exist that have a pair of queens and a pair of kings? All right, so it's a pair of queens. So there's 4 to choose from. I'm picking 2. And, that's why it's multiplication, a pair of kings. So 4C2. Okay, there's nothing fancy about this. You don't like multiply it by another number. It's a 4-card hand. So here are your 4 cards. And I'm picking 2 and 2. Right? 2 that's a pair of queens and 2 that's a pair of kings. So 6 times 6 gives you 36. All right, and last one about how many 4-hand cards exist. They have 2 face cards and 2 aces. So, well, it's 12 face cards, and I'm picking 2, and 4 aces, and I'm picking 2. So it gives you 66 times 6. Ooh, the evil number equals 396. Okay, so that's it with combinations. But remember, they're card problems. The order's not important. When you switch to to permutations, then order is definitely important. Okay, you got to be really, really careful about that. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.